Hello, I'm Avinash Upadhyaya, and in this video I'll be attempting the Pulumi challenge called Startup in the Box. Pulumi is an infrastructure as code tool that allows you to define and automate your cloud resources using programming languages such as Python, TypeScript, Java, C# or Go. The idea of the challenge is to set up a static website on Amazon S3 with a CloudFront CDN exposing it and using Checkly to synthetically monitor the static website, all using Pulumi. I'll also be setting up a custom domain for the CloudFront CDN using Route 53 and AWS Certificate Manager. Before we continue, I want to apologize if the video turns out to be a long one or if there are a lot of background noises that you hear throughout the video. There are a few prerequisites that are necessary for completing the challenge. The first of them being a Pulumi account. A Pulumi account is a backend service for the Pulumi programs. The backend service stores the state of a Pulumi program, which is the current configuration of the cloud resources that are being managed by the Pulumi program. So I've signed up for the Pulumi account using my GitHub account. And the next prerequisite is to have the Pulumi CLI installed locally. I have installed the Pulumi CLI locally and also authenticated it with my Pulumi account using the Pulumi login command. I can verify that using Pulumi whoami to verify that I've logged in as my GitHub account. And the next prerequisite is to have an AWS account. I have set up an AWS user with permissions for Route 53, AWS CloudFront, AWS Certificate Manager, and also Amazon S3. I have also authenticated this user with my local AWS CLI using the AWS configure command. And the final prerequisite is to have a Checkly account. I have signed up for Checkly, free Checkly account. Alright, let's get started with the first step of the challenge, which is to create a Pulumi project. A Pulumi project is a directory which contains a collection of Pulumi programs. I have an empty directory over here which I'll use to initialize the Pulumi project. The Pulumi new command is used to bootstrap a Pulumi project, and I'll set the project name as Pulumi challenge and leave the default description. And Pulumi stacks are a way to define different configurations for the same Pulumi program. I'll create a stack called production, indicating that this is the production environment, and also set the AWS region to the Mumbai region, which is the closest region for me. Pulumi will now go ahead and install a few dependencies that are necessary for running the program. Once the dependencies are installed, we can now open the current directory in Visual Studio Code and start modifying the Pulumi program to define our cloud resources. The Pulumi starts execution with the index.ts file. We will start with creating our first resource, which is an S3 bucket, and associating an ACL with the public access to the bucket. I'll replace the bootstrap code with the code from the challenge page, which is creating an S3 bucket and an ACL associated with it. Now let me run Pulumi up, which will show us a preview of the resources that will be created through the program, and also create the resources upon approval. Pulumi is suggesting that it will create a stack called Pulumi challenge production and also a bucket called bucket v2 and associate an ACL with it. I'll select yes to go ahead and deploy these resources onto my AWS account. Pulumi has now created these resources for us. Let us now start with adding a few static files onto the S3 bucket. In order to copy the MIME data of the static files, we'll be using the Node.js library MIME and installing it using npm. I'll add the code snippet for copying the files onto the S3 bucket. The code snippet is going through each file in the directory called website and copying them as a S3 bucket object onto the bucket that we had defined earlier. So I'll also create the directory called website and a file called index.html inside the website directory, and place the contents of the HTML file inside the index.html file. I'll also create a style file, style.css file for the styling of the website. Replace it with the style from the challenge page. And additionally, you can also add a normalized.css file to ensure that the website works on all browsers. And finally, we'll create a CloudFront CDN to expose the S3 bucket that we've just created using CloudFront. So this particular code snippet is creating a new CloudFront distribution that is associated with the bucket that we had just created, and also a few other configurations that we are providing. I'll also add the country that I am currently in, India, as a whitelisted region, so that I can access the website from the region that I am in. So now we can once again run Pulumi up, which will show us a preview of the resources that will be newly created and create them upon approval. I'll select yes to create the CloudFront distribution and also upload the 2 static files onto the S3 bucket. Pulumi has now created CloudFront distribution for us. In order to get the URL of the CloudFront distribution that we just created, we can export the URL as an Pulumi output. We can do that using the export functionality of Node.js or TypeScript, and I'll export the URL as the CloudFront distribution that we just created, CloudFront distribution dot domain name. If I run Pulumi up once again, Pulumi will recognize that we've just added an output and not created any new resources. So I'll also skip the preview using the skip preview command and directly go with performing the update, which is to just output the URL. So we have the URL or the domain name of the CloudFront distribution as an output. Let us go ahead and verify if the static website is up and running. It is. So in order to completely leverage Pulumi's powers, we can now go ahead and create something called a component resource. A component resource is a collection of related resources which can be used as components or a reusable component. So I'll go ahead and create a directory called CDN website and create a file called index.ts, which will host the component resource that we will be defining. This component resource will contain this exact same resources that we've just defined, but as a single component. So we're defining a component resource and creating a bucket, an ACL associated with it, and a CloudFront distribution with the same exact configuration. I'll also add the India region in the whitelisted list, and we're also copying the static files onto the S3 bucket. And finally, we're also exporting the CloudFront distribution domain name as an output. So let me go to the main index.ts file that is in the root of the directory and clear everything. Now all we'll need to do is just call the component resource that we've just defined from the main index.ts file. Pulumi will now go ahead and create the component resource for us. There seems to be an error in the spelling. Let me fix that. So now Pulumi will be able to create the component resource for us. Pulumi up. Pulumi is suggesting that it will go ahead and delete the earlier resources that we just defined and create the same set of resources but under the component resource called CDN website that we've just defined. I'll select yes to perform this update. Pulumi has now created the same set of resources as a component resource. Now, before we proceed with the challenge, I want to customize it a little by adding a custom domain for the CloudFront CDN that we just created. I'll be using Route 53 as the DNS server for the custom domain that I'll be providing to the CloudFront CDN. Let me start by adding a Route 53 hosted zone. So I'll be using a concept of Pulumi called configuration to import the value of the domain name that I will be providing to the hosted zone. I will also add the code snippet for creating the Route 53 hosted zone with the domain name that we've just imported using the Pulumi configuration. In order to set the domain name, we can run Pulumi config set and domain name, which will allow us a prompt to set the domain name value, which is avinashupadhyaya.live. And finally, we'll also need to propagate the list of name servers of this hosted zone onto my DNS registry, which is name.com. Name.com does not have a Pulumi provider, but I'll be using a concept of Pulumi called dynamic provider to create a provider on the go and communicate with name.com using Pulumi. I'll start by creating a file called name.com, a directory called name.com, and a file inside the directory called index.ts. Let me populate the contents of the file for the dynamic provider. We'll also need to install the GOT library in order to communicate with the name.com API. So the dynamic provider is using the name.com API to set the name servers. This is the API that it is calling. I've also defined a few interfaces for the input and output structure of the API, and the name.com provider has a create method which will be called whenever the provider is called, and it is calling the name.com API using the credentials that we'll be passing as once again as a configuration. I'll be passing these values as secrets so that they are encrypted in the configuration file and is not publicly accessible. I'll save this file and import this provider onto our main index.ts file and call the provider from the index.ts file. We'll also need access to the name servers of the Route 53 hosted zone, which we can get through Route 53 zone.name servers. And now we are importing the name.com provider and calling the name.com provider with the domain name that we've just imported as a configuration. Now we'll also need to set the secrets for the name.com username and name.com token. I'll start with setting the configuration for the name.com token as a secret. And also provide the name.com username once again as a secret, so that it is not available in plain text. I'll need to run that once again to ensure that the value is set appropriately and did not make any mistakes. And finally, now we can run Pulumi up to preview what resources are being created. There's also a command called Pulumi preview, but I'll be using Pulumi up to preview what new resources will be created after our current change. Just to recap, we have now created a Route 53 hosted zone and also set up a dynamic provider for name.com and setting and sending the name servers details of the Route 53 hosted zone onto name.com. Pulumi has now created two resources for us. One is the Route 53 hosted zone and also the dynamic provider resource, that is to upload these name servers onto my name.com domain registry. The next step in creating a custom domain for the CloudFront CDN would be to create a certificate in AWS Certificate Manager and provide that certificate to the CDN distribution in order to validate the ownership of the domain, and also create a record in the Route 53 hosted zone pointing to the CloudFront CDN. So I'll start with modifying the component resource that we had defined earlier and provide some structure to the component resource by defining an interface for the arguments that are passed to the component resource. Earlier the arguments had a type of any. I'll be changing that to the interface arguments, and I'll also be setting the IPv6 configuration of the CloudFront CDN to false, so that there is no IPv6 addresses created for the CloudFront CDN. This is because if there is an IPv6 address, we'll also need to create separate records for IPv6, and in order to keep it simple, I'll be avoiding that. And I'll also add a field or configuration for the alias for the CDN distribution with the custom domain that we want to provide, which is the subdomain dot the main domain. And finally, we'll also create or provide the AWS certificate manager certificate onto the CloudFront CDN. We have not yet created the certificate yet, but I'll be adding that over here, replacing the default certificate that is used by the CloudFront CDN. And finally, we'll also add the code snippet for creating the Route 53 record. We'll also need to define this Route 53 record inside the component resource as follows, right? So we're now creating a Route 53 record, which will be a type A record pointing to the CloudFront distribution's domain name, and in the CloudFront distribution's hosted zone ID. So let us get back to the main file, the index.ts file, and create the AWS certificate manager, and also create the certificate for the custom domain that we have. So I'll start by creating a cloud region, that is the East region, since AWS dictates that the certificate for the CloudFront CDN needs to be present in the US East 1 region. I'll start by creating a region for US East 1 and use the Pulumi provider to define that region. And the next step would be to define the set of arguments for the certificate, all using Pulumi, and create the actual certificate, and also a validation certificate for the domain and the subdomain. So we're now this needs to go up. I'll also define the subdomain as Pulumi challenge. So now that we've modified the component resource, it expects a list of arguments that we've provided. So I'll modify this particular snippet as well to include the list of arguments that we will be passing to the component resource. So if I run Pulumi up now, it should go ahead and create the certificate in the certificate manager and provide that certificate to the CloudFront distribution, and also create a record in the hosted zone for the CloudFront. Pulumi has now created the AWS certificate and also validated it and provided it to the CDN distribution, along with creating a record in the AWS Route 53 hosted zone. Now let us continue with the original challenge and add another provider for Checkly. Checkly is a synthetic monitoring tool, and I'm not sure if you all see it, but I do have a t-shirt from Checkly that I'm wearing right now. Yep. So Checkly will be installing the Checkly provider using npm, and also provide a couple of configuration values that are necessary for Checkly, such as the API key and the account ID. The API key is a secret value that I'll be providing to Pulumi, and the next configuration value is the account ID. So now that we've set the two configuration values, let us now add the source code for the Pulumi Checkly provider. I'll be adding it in the same index.ts file, that is the main index.ts file. It is now expecting a website.url, which I will be providing as the custom domain that we've defined earlier. So the website URL is the subdomain.themaindomain.com, and I'll be modifying this snippet to remove the apply part, since earlier the example from the challenge was using a Pulumi output, which has the apply method to actually extract the string value from the output, but here I will be using the actual string and not the Pulumi output. So all this provider is doing is creating a synthetic check that will constantly run every 10 minutes and open the Pulumi page in a browser, and from the location that we've specified here, I'll be changing it to the Mumbai region once again, since that is the closest region to me, and it is expecting a script which will define the set of actions to be performed for the synthetic check. We'll go ahead and create the checkly embed.js file, which will contain the script for performing the checks. And we can now copy this from the challenge page. So the script is opening a Playwright browser and opening the page and checking for the title. I'll also modify this further to add an additional check for checking the HTTP status code apart from checking the page title. So I'll capture the page response in a variable called response and add a check to check the status code of the website. And now that we have defined that, I'll also modify the checkly snippet to actually perform additional activities such as creation of an alert configuration, since I want to be alerted whenever the checks are not performing as expected. So I'll start by creating an alert channel for sending the alerts from Checkly. I'll define an email channel and use Pulumi configuration to read the email value. So the value will be email, and also provide this alert configuration onto my monitor configuration, so that any issues in the monitor will be reported as an alert to my email. So we can now run Pulumi up, and I'll skip the preview for this one to directly deploy the resources. We can ignore the warnings, since that is very specific to the architecture that I'm using on my machine. Pulumi has now created the two resources for us, that is the Pulumi check and also the alert channel. We can verify by visiting the Pulumi or the Checkly dashboard and verify that we have a monitor created through Pulumi. So we do have a monitor index page that was created and is still in a pending status because it was just created. And going back to the challenge now, we are in the final step of creating a dynamic provider. So we have already looked at what a dynamic provider is and created one for name.com. We'll now create a similar dynamic provider for a custom Swag provider that Pulumi has set up for completing this challenge. I'll go ahead and create a directory called Swag provider and a file called index.js inside that directory, index.ts inside that directory, and paste the code from the challenge page. It is once again performing the same action of calling the Airtable API using the concept of dynamic providers in Pulumi. And we'll need to now call this dynamic provider from the main index.ts file, which is this. I'll provide my name and I'll be using the configuration value email for the email, and also provide the address in a similar fashion of reading it as a configuration variable, and provide the size for my Swag. I'll once again read the address as a configuration value, and and I'll need to set the address using Pulumi config set, and I'll be setting it as a secret. Now let us go ahead and run the Pulumi up command, and once again skip the preview since we're just calling one provider, which is the dynamic swag provider. Pulumi has now created one resource, which is the dynamic swag provider, which does mean that Pulumi has called the Airtable API and sent the details of my submission to the Pulumi Airtable. So that was it for the challenge. We can now verify if our website is indeed working using the custom domain that we've set up earlier. It depends on how long Route 53 and your domain registry takes for propagating the changes. So we see that it is working in the URL pulumichallenge.avinashupadhyaya.live. We see that our static website is hosted with a custom domain. So that was it for the challenge, folks. Thank you for watching till the end, and see you.